So why learn C? C is the mother of all mid to high level computer programming languages. So what does that mean, mid to high level? Well, first let's talk about low level programming languages. Low level is when you're talking to the computer very close to the machine itself. This is the zeros and ones, binary, or assembly, which is pretty close to zeros and ones, but a little bit more user-friendly, but still very close to binary. Hard to understand, hard to write out, it takes a long time to figure out what you're trying to write. Which brings us to the other end of the spectrum, which is high-level computer languages, which is like Python, JavaScript. These languages use something called an interpreter to help the programmer himself write the code a lot faster, be able to debug faster and test the programs a lot quicker. It kind of makes things go a lot faster for the programmer, but not for the computer, because since it's so high level, uses an interpreter, creates an abstraction layer that takes a lot more time, CPU processing, RAM, bandwidth, and other resources that the computer needs to use to process that information. Which brings us to mid-level computer programming languages. A little bit slower than low, a little bit faster than high, but it's in the sweet spot in the middle. And this is like C, C sharp, C++, Rust. So I said a few C words here. What are the differences between these C words? Well, C is the original C language of all the C languages. Now C++ is basically extension. It's like an expansion pack for the C language. It kind of changes the syntax a little bit here and there. It also adds the opportunity to do object-oriented programming. And then there's C Sharp, which is Microsoft's personal take on the C language built on their .NET framework.
Install our compiler. We're going to go ahead and install it. I actually already have it installed, so I'm going to use this great guy's video on the further steps of installation. Once it's installed, go to your control panel, Systems, Advanced System Settings, Environment Variables under the Advanced tab. Double-click on Path, click on New, and find where you've just installed your compiler. Find the binary folder, copy it, and put it into a new field. Now hit OK. OK. We're going to go to our command prompt and type in gcc-v to verify it's installed. Next, we'll install Visual Studio Code. I also have this installed, and if you have any issues with it, please let me know and I'll help you out. When it's installed, we'll go to the extensions and install C, C++ by Microsoft. We're also going to install Code Runner by Yoon Han. Go ahead and create a new project. We can make a new folder wherever you want. Name it anything that you want. We'll make a new file called main.c, or you can name it anything you want, as long as you type in .c at the end. Now let's go to the Terminal tab and click on the C, C++ compiler. Let's select that. This then creates a tasks.json file. This is essentially metadata of how the compiler is going to launch your code. If you go back to the directory that you created your code for, you can see that it also created a new file there. Now let's go to File, Preferences, Settings, go under the font and change the font size. I'm just going to do this so you can see what I'm doing a little bit easier. We're also going to go under File and Set and enable autosave. Now the first thing we're going to write is a hashtag include. Include is just a preprocessor command that tells the compiler to include the contents of a specified file. And the file we'll be using is stdio.h, which stands for Standard Input Output, and the file type is an H file. The file contains the commands and keywords we will be using in this script. Int is the function type we are creating. This is a key word in C. Main is just the name that I gave it. You can actually give it whatever name you want. You can name it apple, chair, dog, but let's name it main just to get into the habit. And the parentheses and braces and the symbols are going to look a little alien at first, but the more you use them, the more you get used to them, and the more you understand that they are just the grammatical punctuation marks that a computer uses to understand what you're saying. Return 0 means that if our program doesn't have any errors, it will return a 0. But if it has an error, it will flip that 0 to a 1. Printf is one of the key words from this stdio.h file. You see, if we didn't write this include statement at the top, then C wouldn't know what printf means and wouldn't know what to do with it. But since we specified what file we are using, anytime we write one of these keywords, the compiler will look at the reference file we are using to know what that keyword means so it can execute our program. To the top right-hand corner and click on the little play button, or hit the drop-down menu and click on Run Code. In this case, we have an error, so it returns the error code, which is 1. And the error is I forgot the F. So I'm just going to type out a little sentence here just to kind of play around with it. And you can type out anything you want here, as long as it starts with a printf and you put a semicolon at the end and you have your string in between your quotes. Now let's try running this manually without VS Code. You do this by opening the command terminal and navigating to the directory which our project is sitting in. And now type gcc followed by the file name. Oops, I typed in .exe. It's supposed to be .h. Now after you type that, it creates a new exe file, an executable. So go ahead and run that. And that's how you run it manually. But let's go back to VS Code. If you run it like this, you'll notice it displays it all in one line. If you want to separate the lines, you have to specify that by adding a \n in your string at the part where you want to skip to the next line. Let's talk about comments. Comment is a note that is written for a reader and ignored by the computer. You can type in any comments you want here. And if you want to add multiple lines of comments, you do a / and a star. And then you end it off with a star and /. And if I run it, you can see that it did not write out my comment. So \n creates a new line. A new one we'll look at is \t, which adds a tab. We can create something cool, maybe like a grid shape, just by playing around with the new line and the tab commands. It looks ugly on the screen, but when you run the code, it looks kind of cool. So as you can see, I'm writing out this little grid layout. So we got A, B, C, D, E, F, G, H, I. And then we got like this 3x3 cool looking grid. And here's a way to use the / to actually display our double quotes if we want to use them. And we can look up an escape sequence cheat sheet. We don't have to memorize these, just know where to find them.
Variables are like association words. When you hear the word cat, what do you think of? You most likely think of a cat.
Let's analyze the word cat. The word cat is a noun. The word cat itself doesn't mean anything unless you associate it with something that exists. This fluffy, cute, meowing thing is the thing that exists. It is the noun, and we named it cat. This is the way that computers see variables when programming.
Now with variables, there's different types of variables. Just as when you're in elementary school as a child, we learned that there's different types of words. There's words for nouns, verbs, adjectives, and numbers. Just as we talk to a computer, when we program a computer, when we talk about variables, it's like we're teaching a little kid in elementary school. So think of a computer like that, and think of our variable syntax and vocabulary like that. See, now we have to specify every time we say a word, a variable, to a computer, we have to tell it what kind of word that's gonna be. See, with humans, we have a noun, we have a cat, and we could say that the cat is a tabby.
So the way that we described it as a human, noun is the type of word that we're using, cat is the name that we're going to give it, and tabby is the actual breed that the cat is. Now, if we were to tell the computer what age the cat is, we would type in number. That's the type of word that we're going to use. We're going to name it 5 pounds, and we're going to assign the value 5. And we could change this name to kilograms. We can make this anything we want, but what's important is that the 5 is a number that matches the variable type, the data type. But now let's take a step back. Computer doesn't know what the word noun is, and it doesn't know what the word number is. Instead with C, it's going to be char for character, and number the computer knows as int.
When we talk about cars, a car is also a noun. The same thing goes for numbers. If we're going to talk about the number 5, for example, computer doesn't know the word number or the word 5, but it does know the word integer. So integer, we have to tell the computer, hey, I'm going to tell you an integer, I'm going to name it number 5, and the value associated to my name that I gave this integer is 5. It's fucking sick. So now I am walking. Now what is the word walking? Walking is a type of word, and that type is a verb. It's an action word. So you know, when you're talking to a computer who's essentially like a little kid, you want to say, hey, the word I'm about to tell you is a verb. It's an action word, you know, it's not an object. I'm going to name that word Adam, because that's my name. And the value I'm going to give Adam is walking, because that's the value that the computer is going to associate with that kind of word that I give it. So that's an action word.
So here it is written out, verb Adam walking, except the way that you write this, character Adam with the 2 brackets and walking. So let's talk about the data types for all of these variables we're talking about. So the first one is char for character. We're going to name our character A, but the value itself is going to be an actual character, which we'll name C. And the way that we call this character is doing a %C. We'll talk about this soon. So the second variable type is char B with these double brackets. It looks a little weird typing it out this way, and programmers recognize this. That's why in modern programming languages there's something called a string for words or for sentences. But in C, it's a bit older, so this is the way that they did it. They used the variable character, the brackets to indicate that there's an array of characters. Float is a partial number, or some kind of decimal point. The way to call a float is %f. A double is the same thing as a float, but you can have a lot bigger of a number. You could be a lot more specific with what number you're creating. You see, a float, it goes up to 32 bits. And after that, it might display more numbers, but it's not going to display them accurately. Whereas a float goes all the way up to 64 bits. And in order to call a double, it's a %lf. A bool is a true or false function. You call it with a %d, but you also need something called stdbool.h to work, which is a separate library that C actually knows about if you specify it. So we'll go up to the top and we'll include this stdbool.h, and you'll notice that these red little squiggly lines under bool and true goes away. The next one we're going to talk about is another way of saying character, and in this method we can do either a %d or %c. There's two options. %c converts the number to the ASCII equivalent of that character, but %d just displays the number as is. And this is the way that you would print this out. So you would do print %c. C is specifying that we're going to be using a character type. If we go to Google and look up an ASCII table, 100 is equal to a D. The next one is unsigned character. An unsigned character does the same thing as the one above it, but the only difference is we're going to be using a number that may or may not have any kind of ASCII code associated to it. Next one is short integer. So with this one, we can have a short number that goes up to 2 bytes. And again, we can type out a bigger number than that, but if we do it, it's only going to display the first few numbers correctly. The rest of the numbers might be wrong. The next one is long int. Long int could be also typed out as just int. When you see int in some kind of number, that is just the default way of typing out long int. So long int only stores whole numbers, no decimals, and it contains up to 4 bytes of numbers. Long int is also the same way of saying just int by itself. So int by itself is actually just long int, but the shorter way of doing it is just int. An unsigned int is essentially the same thing as a long int, but we can add a letter to the end of it. We might just use a character such as U that ignores warnings and errors. Our next data type is long int. This is the same thing as long int, but you just make an even bigger number, up to 8 bytes. And now we have unsigned long int, which is the same thing as before. And here let's try adding a U to it. So as you can see so far, we have A, B, C, D, E, F, G, H, I. Oh, I think I missed one. I missed the I. The I was the unsigned short int. So we have J, K, L, M. We can call the first one that we created, which is we named A, which is our first character, which should be a C. But so we use %C to run it. The next one we named as B, and we need a %S to run that. Our float is this number, so we're going to call it by using C, and we'll need %F. The next one is a double, so we'll use the D to call this big long number. We're going to use the %LF. The next one is our Boolean, which is true, and we'll use %D. Now if we run this, we'll get a number 1, which means true. Our next one is a character, which is the F, we're going to call it with C to get that ASCII code. And if we use a D, we'll just get the number. So our next one is our unsigned character. And as you can see, it's a little question mark. It's not like nothing that we have like processed, or I don't know how to explain it. It's just like a character that doesn't exist. So for the short integer to get this number, we'll use H and a D to call it. For the unsigned short integer, we'll use the I, and this also uses a %d. The long int, to type out this big whole number, we'll call %lld, and our name was L. Now to type out our long unsigned integer, this big long one with the U at the end, we'll do LLU and an M. And as you can see, there is no U that got printed out for that number. But if there was a warning in that number, it would just ignore it because of that U. So now we know all about variables and data types, right? Yeah, I know. If this is your first time seeing all this, it's a lot to wrap your head around and probably doesn't make a lot of sense. Don't be too hard on yourself. Don't beat yourself up about it. This is one of those things you'll get better with time and repetition. The more times you look at this and the more times you do hands-on practice, the better you'll get. Just don't give up no matter what. So here we're just going to play around with some variables and data types. So these are some floats, which are numbers with decimals in them. And wherever you would like to add a variable, you can also add it with a $sign followed by the %. So in this case, we're just creating some items. Like let's say we own a store. So item number 1, and we're going to do item number 2 that costs $2.45. I'm just going to copy and paste these just to make it faster. And as you notice, I've added a little .2 at the end. And they're all on one line as well. So maybe we should clean this up a little bit by doing the \n. Yeah, that looks a lot better. So now what is this little .2 after the %sign? Well, if I were to do a .1, you'll notice that it will only print one number after the decimal. And if I do a .0, it's not going to print any numbers after the decimal. And you actually notice that it also rounded to the nearest number. So our 5.55 became a 6. Now let's talk about constants. Constants are a fixed value that cannot be altered by the program during the execution. It's something that doesn't change no matter what conditions come up afterwards. So we'll create one by saying constant float. We're going to name it pi. As you can see, it's caps lock. You don't have to write your constant variables in caps lock. You're not going to get an error if you don't, but you should get into the habit of always using caps lock for your naming conventions when you're working with constants. And that's just because it's the best practice and just a standardized way that the community of programmers have been kind of sticking to. So whenever coworkers or even yourself later down the road, when you come back and look at your old code, you will see the caps lock variables and right away recognize that it's a constant. And that's all there is to constants. So now let's get into math. We're going to talk about some arithmetic operators. We've got addition, subtraction, multiplication, division, modulo, increment, and decrement. So we'll go ahead and assign a few numbers. Int x equals 5, int y equals 7. And int z equals 5 plus 7. So z is just the other two just combined. Now we can print it out. And as we remember, the percent %d is what you call to get a integer. And z is the value that we're going to print out. Oh, I forgot the f. Let's try this again. The best part about math when you're programming is you don't have to be good at math. You just need to know the formulas. You just tell the computer what the formula is, and the computer calculates it for you. Because I'm really not good at math. I've never been good at math, but it's kind of fun with the computer because now I just have to figure out how it's done. I just need to learn half the work, and the computer does the other half for me. So it's kind of a fun way to hack math. Now, if we want to add a float, there's two ways we could do this. We got to specify that one of our integers is also a float. And now we can add a decimal. And the percentage for float is an F. So as you can see, now it can return decimal values. And we can round that down to a 1/10. Another way we could do this is just specifying one of our integers as a float instead. So that works too. Now let's talk about augmented operators. So augmented assigned operators are used to replace a statement where an operator takes a variable as one of its arguments and then assigns the result back to the same variable. Basically, what that means is it's just a shortcut to do math for people who are lazy. And you don't have to be lazy to do this, but it could be fun, it could be effective. Sometimes it's the best way of doing things. So here is a number z equals 10. If I do z plus equals 2, all that means is z plus 2. So 10 plus 2, which is 12. Now I can do z subtract 3. So this is z take away 3. So now 12 take away 3 is 9. And now z is now 9, so we're going to multiply that by 2. And now z is 18. So now z is 18, we're going to divide that by 2. And now z is 9. So now that z is 9, we're going to do modulo, which is divide by 2, but just give us the remainder, which is 1. Now let's bring in a new library related to math. We'll do this by including a new H file named math.h. Math.h just has extended math functions. It's like an expansion pack for your math. So we'll just create a few doubles here, a few integers. So in order to call our double, we'll do %lf and use the name that we assigned to it. But we haven't assigned any values to it yet. So let's try this out. The first one is square root, and the number inside is the one that we're going to perform the operation on. So this means square root. And if we run this, we'll get the square root of 6. And now for our b variable, we'll do power, which is a power root, meaning we got 3 with the power root of 5. And I'm going to get an error because I spelled it wrong. It's actually POW, not PW. And now for our c variable, we're going to use round. And this rounds to the nearest number. So 5.17 is going to round to 5. And looks like I'm getting an error here. And that's because I didn't change the percent sign. It's expecting a float, but it's only getting an integer. So we got to call it properly. And an integer, it was not f, it was d. So remember, integers are d, and doubles are lf. Our d variable is going to be ceiling, which is ceil for short. Now ceil always rounds up. So a 5.17 is going to round up to a 6. E is the opposite. E is the opposite, floor. Floor always rounds down. So even if we have a 5.99, it's going to round down to a 5. And now we're going back to doubles. So fabs is it gives the absolute value of a number. So the absolute value of -50 is going to be, remember to change our percent to an LF. And instead of an E, we'll call F, because that's what our fabs variable is called. And for -50, our absolute number is 50. So our G is going to be logarithms, which is some kind of math thing. I actually don't think I've ever done it before in math. So if anyone's worked with logarithms, let me know what they are for. Now we're getting into space of trigonometry. So h is going to be trig sin or sine. The next one is cosine. So we just use cos for short. And then with j, we're going to do tangent, which is tan for short. And was there an e at the end of cosine? Was there an e at the end of sine? I don't remember. You can tell I never really did math that much in school. Maybe I should do a math course next. Get myself up to speed. Now we're going to calculate some circles' circumference. So we'll do a constant double pi in capital letters, all right? And we'll type out the value of pi here. And we're going to use a double radius, double for circumference. So these are our unassigned variables, We're telling it what the data type is and what we're going to name it, but there's no assigned value yet. So here we'll do a print statement, enter the radius of a circle, and we'll do scanf, which basically scans for a user input. And it's looking for a double with the %LF, and it's going to assign that double with that and sign to our radius variable. So now that we've got the user input for the radius, now we're going to do circumference equals 2 times pi times the radius. And then we'll do print. We're going to call upon the data type of the circumference, which is the circumference of the circle is %LF. And we'll do a little. Then we got to call what we're going to be putting in that LF value. Now, in order to run this, we're going to go to File, Preferences, Settings, and we'll type in Code Runner at the top. We're going to scroll down. We're looking for something that says Run in Terminal. We'll check that box, and we'll go back to our code. So now when we run our code, it's going to run in that terminal tab, and we'll be able to type something in down here. So the radius of our circle is 5, and it does our calculation. Now we can add some more parameters. What if we want to know the area? So the area is going to be pi times the radius times the radius again. So we're going to do print. The area of the circle is, it's going to be a double type. And we'll do area. And what did I miss? Oh, I missed the F. All right, enter the radius of a circle, 5. All right, it shows the circumference and the area. So this is what I love about programming. Even though I'm not good at math, all I need to do is go to Google and find the formula for any equation that I want to create. And then I just program it in, and the computer does it for me. So let's do some trigonometry with some hypotenuse. So let's do double A for the side 1 of the triangle, double B for side 2, and double C for side 3. And we're going to get the user to enter side A by doing print, and then we'll need the scan function to actually assign the user's input to whatever variable we want. So LF is going to be the double type, and we're going to assign it to A. And use that ampersand to assign it to A. We'll do the next side, enter side B. And then we'll scan it. We'll assign that to the B variable. And then the C will be auto-signed. So the equation to find the hypotenuse is by doing A times A plus B times B. So side C equals, it's going to be a double assigned to the variable C. Now if we run that, we're going to enter the side A. We'll do 5 and 10. So side C is going to be 11. Now let's do a Fahrenheit to Celsius conversion. So here we can define some parameters like character unit. The float is going to be the temperature. We're going to print out select measurement. Is it going to be Fahrenheit or Celsius? Then we'll scan for the user's input. And we'll put in a little if statement. So we'll get more into if statements in a bit, but for now we'll just do if unit equals C, enter the temperature in Celsius. So if you typed in a C, then it's going to give you this output, and it's going to convert it to Fahrenheit. So %F is going to be your float, and temperature is going to be the value that is going to be the name of your variable that it's going to assign the value to. And it's going to do this equation where it's going to convert temperature Celsius to Fahrenheit by doing temp times 9 divided by 5 plus 32. So the temp in Fahrenheit is, and it's going to give us that temperature. So now, if you were to type in an F instead of the C, it's going to give a different set of parameters. So now we're going to enter the temperature in Fahrenheit, and it's going to convert that to Celsius, which is the same formula but backwards. So now let's run this. And you can see I typed in C a couple times. I'll type in F, and nothing's happening because it's not capital. All right, so now that's capital, it accepts it, and it'll do my conversion. So that's a little annoying that it only accepts it if it's in capital letters, like it doesn't understand. So how you can do this is do unit equals to upper automatically converts it to an uppercase. So now if we run this, it just looks like we get a warning. So anyways, it still works though. We get a warning, but it still works. Does it work with F? Yeah, F works too. All right. Next, we're going to create a calculator. So to create a calculator, let's first define our operator. And we're going to have a number 1 and a number 2. And we'll do the result. So we'll do printf, enter enter an operator. And we'll scan for user input. Then we're going to assign the character to the operator variable. Then we're going to enter the first number, which we're going to assign to number 1, which is a double type. We're going to enter second number. Now we're going to use a switch operator, which is kind of like that if statement that we were using in the F to C converter. But it's just called a switch instead of if else. It kind of does the same thing, just a different way of doing it. So here we have a case. Our first case is going to be a plus, and the result is number 1 plus number 2, and it's going to print out the result. And then we add a statement that says break. Add a little punctuation here. So now we can just copy and paste this. And all we gotta change are the little symbols. That's it. Makes it a lot easier to just make a whole bunch of these. Easier than the if else statements. And then we can add a default in case the user puts in something that was not expected. And if we don't add these breaks, then it's just gonna run every single one instead of running the one that you want it to run. So default is just like your emergency parachute. And looks like we got an error here. It's on line 39. Oh, I missed the F again. All right. Now we can enter our operator. We'll do plus 5 plus 4. Looks good. Now we can be a little bit more specific of what the user can enter. Enter one of these. All right. Enter one of these. Subtract 15, take away 4. It works. Let's try the next one. Multiplication. 10 times 15. So 150, that works too. We'll do, see, I typed in a 20 instead of the divide sign, so it just says not a valid entry. And as you can see, it only gave 2 is not a valid entry. It didn't say 20. And the reason that is because we only specified a character, but we only specified a character. And if you remember back to your data types, in order to specify a character, you do a %C. But if you have an array of characters, you gotta do %S. So because this is a %C, it's looking for just one character. It's not looking for a whole array of characters. So it's only gonna type out the first one. All right, now we're gonna do just a little bit of experimentation with these things. So we're gonna make one that says level. We're getting into some gaming territory here. If you ever played World of Warcraft, maybe you're on my channel a little bit, watching my Warcraft modding videos, we'll do an integer called level, and this one will say, what level are you? So it's going to expect that %d, which is the integer type. So it's going to say you are level. And now we'll type in 5. It says you are level 5. And we can just make it look a little bit neater by adding some spaces. Even add a tab. So what level are you? You can add a tab here too. Just playing around with these. Now let's add a little bit more to it. We can add a class, and in my array I put 25, so this means it adds a maximum input of 25 bytes. So here I'll type in, what class are you? I'll type in what class are you? And we're expecting a string to come in, or a character array in this case of C. And with the %C, we're expecting a character array to come in, and we'll assign that to class. So whatever the user puts in, we're going to assign that character array to the class variable. So here we can do you are a level, and we'll call our level variable, and we'll put in our character array variable by doing class. So now if we print this out, it says what level are you? 5. What class are you? I'm a warrior. You're a level 5 warrior. Let's get back to statements and talk about a little bit of the differences between the if and switch statements. So here we're going to type out some grades as if you were in school. So enter letter grade. So we'll get the user to enter a grade. The scan function will then take the character of that grade and assign it to the grade variable. Now we're going to make our actual program here. So if the grade equals, let's say, the character A, see, it's going to be looking for a character. It won't be looking for an integer, not a float, not a string. So if the grade equals A, that's an exquisite grade. Or else if the grade equals B, that's still a pretty grand grade. And else if the grade is C, that's a pretty common grade. If you guys ever played Morrowind, I'm kind of using the naming conventions of that there. And then D, that's a poor grade. We'll copy paste that again. And if the grade is F, it's failed. And finally, if the user put in something that wasn't expected, then we'll just do it's invalid. And we learned something from our Fahrenheit to Celsius that we should always put these to uppercase to make sure that we can type in a lowercase a and it still can kind of figure out what it's going to do. So we'll hit play. We got that little warning, but the program still works. So we'll try B, grand, lowercase c works, a D, poor, F, failed, and E, it's invalid entry. So this is the way to do if-else statements. But if-else statements are fine, and there are places to do it. And if there's just a few different entries, it might be good to use an if-else statements. But something like this, we got like 6 different conditions, so it's easier to just use a grade. It's easier to just use a switch instead of a if-else block. So with the switch, it's going to be a lot easier to look at, simpler to write out, and it's just a better practice overall when you're working with a lot of different options. Here we can just copy paste all of these and just change the differences. And in the end, we're going to add our default block. So in case the user enters something that we didn't expect, it's going to be invalid. Now let's try running this again. We're still getting that warning just because of the 2 upper, but it still works, so it's okay. C works, D works, F works, and our default entry works. Now let's see what happens if we didn't have breaks. Before I mentioned that if we don't have breaks, it's just going to run everything. So now you're going to see that in action. So we'll do A, and it just gives us all of the results. So that's why we know we should be using the breaks. That's what that does. Thanks for watching the video. I'll see you in the next lesson.